What's up guys, it's Simon Fiaz and today's video is on June 2021 A-Level Chemistry Paper 1 AQA. Question 1. State the meaning of the term enthalpy change. Definition question. So enthalpy change. Enthalpy change is the heat energy change at constant pressure. And I'm pretty sure you need all of these keywords to get it right. Heat energy change at constant pressure to get the full mark, the first mark on the paper. 1 point, there's figure 1, complete it. Classic question. So first things first, this bit has to be atomization of enthalpy of atomization of calcium, because how we got a gas here? Well, we must have started with a solid, because calcium chloride is solid, so we'll have calcium solid plus Cl2 gas, and then that's atomization of calcium, which is 193 enthalpy of atomization of calcium, and there's only one calcium atom, so you're not timesing by anything. Calcium. Okay, let's fill in the rest before we even carry on. Well, this is obviously first ionization energy, so therefore this must be second ionization energy. So it's going to be Ca2 plus in grams plus 2E minus plus Cl2 in grams. The Cl2 remains the same. Only thing that's changing is what we're trying to find. We're trying to find the first ionization energy of calcium. So of calcium, we're just going to increase the second ionization energy of calcium. This one's the first. Plus 590 plus 1150. Yeah, so if it's asking for of calcium, we're changing calcium from a 1 plus to a 2 plus, therefore we need to have 2 electrons to get an overall charge of 0, and the chlorine just remains the same. And then this final one, this part here, well, it's going to be electron affinity of chlorine. Yeah, definitely going to be that one. So it's going to be of chlorine. So it's going to be Ca2 plus in grams plus 2 Cl minus in grams. No electrons, charges already cancelled out, 2 plus and 2 minus. Now we filled the figure 1. Ca solid plus Cl2 gas, Ca2 plus 2E minus, Ca2 plus gas plus 2E minus plus Cl2 gas, and then Ca2 plus gas plus 2 Cl minus. Now it wants us to work out, calculate value for enthalpy of lattice dissociation of calcium chloride. Well, we know electron affinity of chlorine is minus 364. Minus 364. And we also know enthalpy of formation of calcium chloride is minus 795. So minus 795. Enthalpy of formation of calcium chloride minus 795. And what we're trying to find is we're trying to find the entropy of lattice association of calcium chloride. And just before I carry on, this should be times by 2 because we have 2 chlorides and we're trying to find the electron affinity of chlorine. So this is how they trick you out. You know, you look at it, you think it's a nice question, which is not a bad question, but you do need to know these small tricks. You know, if you have 2 chlorines, you've got times by 2, etc, etc. So it's going to be minus 795, because that's the entropy of formation of calcium chloride, right? So minus 795 is going to equal to the rest of this. So what's it going to equal to? It's going to equal to 193 plus 590 plus 1150 plus 1150 plus 2 times by 121 entropy of atomization of chlorine, which is, yeah, it's this is entropy of atomization of chlorine. Because think about it, we go from Cl2 to 2Cl, so it's going to be that. That tricked me up a bit, but now we got it. 121 times by 2, because it says 2 chlorines, minus, well, actually add 2 times by minus 364 minus, well, what is the entropy of lattice association of calcium chloride? Well, we've got everything except for this value, and therefore that is going to be the value we're trying to find. So it's going to be minus x, so we're going to subtract x. Now we just, it's very simple, just put in a calculator and then rearrange it and we'll get the value. There's a lot of questions for question 1. Minus 795 is equal to 193 plus 590 plus 1150 plus 121 times by 2, 2175 plus 2 times by minus 364 minus 728 minus x, 2175 minus 728 minus 795 is equal to 1447 minus x. Oh no, and therefore x is going to be 1447 plus, which will give me 2242. X is going to be 1447 plus 795, 2242. So it's going to be positive. Kilojoule per mole to the power minus 1. And then 1.4 says magnesium chloride dissolves in water. And it wants us to represent a process that occurs when entropy of solution is measured. So it's going to be magnesium chloride, MgCl2, MgCl2, which is a solid, arrow, because entropy of solution, Mg2 plus aqueous plus 2Cl minus aqueous not only do you have to remember the definitions of all of these enthalpy things, enthalpy of solution, hydration, atomization, you also need to know how to construct equations for it. So it is annoying. However, if you're willing to lose a couple of marks just because you can't learn any definitions of equation, well then that's fine. But if you want to get the A's and A stars, you should probably learn everything in the spec. The 1.5 says table 2 shows some enthalpy data. Calculate value for enthalpy of solution of magnesium chloride. So we've already got the equation here. Well, it's going to be and the data in table 2. Table 2. Oh yeah, okay, that's thinking. So MgCl2 solid, arrow Mg2 plus aqueous, plus 2Cl minus aqueous, plus 2Cl minus aqueous, and we've got magnesium solid plus Cl2 gas, and the arrows are going to be pointing upwards. Well, we know enthalpy of lattice dissociation of magnesium chloride, so dissociate magnesium chloride is plus 2493. That's the enthalpy of solution of magnesium chloride. Well, actually, that should be 2Cl minus, not Cl2. 2Cl minus. In grams, and that should be Mg2 plus. In grams. The more practice these equations, the more you get it. So we know that what we're trying to find, enthalpy of solution of magnesium chloride, is equal to 2493 minus the 1920 minus 2 times by 364. Yeah, because I wrote this wrong. This is the enthalpy of solution that we're trying to find. This is the delta H of Le. And so if we're trying to find the enthalpy of solution of magnesium chloride, or this bit, we can go from here to here. So yeah, it's going to be 2493 minus the 1920 minus 364. However, the 364 must be multiplied by 2 since we've got 2 chlorine negatives 2. So times by 2, and we get put in a calculator, and we should get 2493 minus 1920, 573 minus 364 times by 2, minus 155 kilojoules per mole to the power minus 1, minus 155. And then 1.6 says enthalpy of hydration of Ca2 plus gas is minus 1650 kilojoules per mole to the power minus 1. Suggest why this value is less exothermic than that of Mg2 plus. And well, we just enthalpy of hydration of Mg2 plus is that enthalpy of hydration of Ca2 plus is minus 1650. So why is this value less exothermic than this value? Well, does it give us any information here? Not really. But if we look at the ion sizes, we'll find out. Because think about calcium is a bigger ion. So we can say that Ca2 plus ion is bigger, hence a lower charge to size ratio. The idea that if we have two, like we have Ca2 plus and Mg2 plus, both of them have the same charges, but one's bigger, well then it's going to have a smaller charge to size ratio, because for that size the charge should probably be bigger, and therefore it's going to be a weaker attraction. Attraction to the, well, it's going to be what in water to the oxygen delta negative, negative in water. Hence, value is less exothermic than Mg2 plus. Think about it. Ca2 plus ion is bigger, hence a lower charge to size ratio. This is not really necessary, but you can add it. It just makes more sense for you guys and for the examiner, but we can add this. So Ca2 plus is bigger, hence a lower charge to size ratio, therefore weaker attraction to the oxygen delta negative in water, hence the value is less exothermic than Mg2 plus. And that is the end of question 1.